thickness, I can relate or calculate the overall EA as a function of the individual EAs for each ply. Now, I know I'm skipping steps here, but if you are having difficulty, let me know and we can cover it again. Now, how good is that? All I said was that the total EA of a laminate is just the sum of the EAs. Well, that's the stepping stone in calculating stresses and strains in a whole laminate. To do that, we need to define the so-called stress resultants. Basically, we need to simplify things a little bit. And instead of stresses, we will use forces per unit width and moments per unit width. This is done by integrating over the laminate thickness. Remember, our laminate is what's shown here on the left, and the coordinate system as shown has the positive forces and moments as shown. So this is the sign convention. If it's not the same as other courses, this is the sign convention. The other courses should be aware of this sign convention. In fact, that's all the composites books use that, so we're using the same one. Basically, we say if I take the sigma x, the stress in the x direction, and I integrate it through the thickness z, I can call that quantity nx, which is a force in that direction. It's force per unit width. We'll see that in just a second. Similarly, if I integrate sigma y, I will get the ny, and if I integrate the tau xy, I will get the nxy, which is the shear force per unit width. And if I then multiply by z and do the same integrals, then you can show that these are actual moments per unit width, mx, my, and mxy, with their orientations, positive and orientations as shown in this picture. So let's look at the case of the uniaxial tension that we were doing here. I have width W and thickness, total thickness H, and I'm applying a force in units of force or a force per unit width Nx. Now, the average applied stress, sigma 0, is by definition my applied force F divided by the cross-sectional area, W times H. But also by definition, the average applied stress is the integral from the bottom to the top as a function of Z. And if the thickness is total H and my origin is in the middle of the laminate, it's the integral from minus H over 2 to H over 2, multiplied by 1 over H to make it into an average. So if I then recognize that this quantity with the integral we just defined at the top here of the page as Nx, I can substitute and arrive at the relationship that says my applied stress, average stress, is this force Nx divided by the thickness of the laminate. So if I take my force per unit width and divide by thickness, I arrive at the obvious thing, a stress. It's just that most people don't recognize that this is force per unit width. It's not force per unit thickness or anything else. It's force per unit width, which divided by the total thickness